Hello, this is Ivana Reynoso, and welcome to this presentation. In this video, I am going to talk about the Test-Driven Development Approach, or TDD. So, what is TDD? It is a software development approach in which test cases are developed to specify and validate what the application code will do. The main idea behind it is that before you write a single line of code, you first write a test for it. In other words, writing code that tests our code. With TDD, we don't wait to have a finished application because we are testing our source code as we write it. TDD means a change in priority, which has a huge impact in the way software is developed. It aligns very well with the incremental upload of agile methodologies because the goal is to design and develop software in parallel. It involves iterating between testing, coding, refactoring, and understanding the requirements in a truly agile way. This approach usually gets a lot of pushback from most software developers. Before we dive right into it, let's try a small exercise. Can you think about why is test-driven development important? Please pause the video and try to figure out possible benefits of using this methodology. I will give you 10 seconds. Okay, so with TDD, we find out about bugs at an early stage because we are unit testing our code. A kind of testing we do as programmers, not as end users, to prove that a single class or individual method works the way it is supposed to. Therefore, we improve the quality of our code. It keeps software developers focused on requirements before even writing code. Also, TDD gives us confidence to refactor because it allows us to instantly validate any changes we make in one place and verify it doesn't break something we did earlier, making our lives much easier when building applications, adding features, and fixing bugs. TDD, in a nutshell, has the following simple steps. First, we write a few tests. Then we go red bar, meaning we run and watch all the tests fail. Any new test should fail for expected reasons. Nothing is implemented yet. Next, we write simple code, the simplest thing that could possibly work to pass. After we pass all our tests and go green, we go ahead and refactor the code as needed. Lastly, we pass all our tests again to ensure the functionality is preserved. The goal here is to repeat this cycle for each new feature or functionality in your program. Refactoring becomes very easy in TDD because you always have the set of test cases to make sure you're not breaking anything when making any changes. However, you don't refactor every time you write a new test. It is an optional and useful step whenever your code is becoming redundant, hard to read, or your code just doesn't feel right. Creating a test with a test-driven development mindset is about starting the incremental cycle of software development with a failing test case. At the start of every iteration, we prioritize use cases and decide which one to be implemented. Next, we determine their acceptance criteria according to their respective requirements. And with that, we can determine a good starting point for a unit test case. When it comes to best practices for test-driven development, the following conventions should be followed. First, you want to name classes and methods meaningfully to indicate what they are testing. Adding the word test is a common practice. For example, if my concrete class is called message, I would name my test class message test, and my test cases or methods would be test display message or test erase message, for example. Typically, you start with one test class per code class, although there is no rule that a test class cannot test more than one concrete class, or that one concrete class cannot be tested by more than one test class. Also, you want to keep your code and test classes separate to manage your project better. So, it is recommended to have two packages in every project to keep the source code in the source package and the test code in the test package. There are established XUnit testing frameworks we can use to write automated test cases that provide assertion-style test validation capabilities and result reporting. The unit testing concept works for multiple languages because most of these testing frameworks are based on the same ideas. For example, there is NUnit for .NET, PyUnit for Python, CppUnit for C++, OCUnit for Objective-C, and many more. These libraries shared the same core ideas on how to create, run, and manage automated unit tests. A key concept in unit testing is assertion, which simply means stating something to be true at a particular line of code, often referred as a sanity check in coding. It is possible for an assertion to be wrong. However, if it is wrong, either the application code is broken or my assumptions about what's going on in the program is. In JUnit, for example, there is the assert equals method. It compares whatever two objects you are assuming to be equal. The first argument is the expected value, and the second argument is the actual value. So, as an example, let's say I have x of type int equals 5 and y also of type int equals 8. If I say assert equals 5, x, this will pass and do nothing. Now, if I say assert equals x, y, that assertion is false and will immediately throw an error and fail. There are other methods available that evaluate if two arrays are equal, if a condition is true or false, if the object references are the same, if an object is null, and so on. Here is another exercise. Please pause the video and see if you can guess the outcome of these two assert statements. Will they pass or fail? I will give you 10 seconds to do that. Okay, ready? If you said they both pass, you were correct. The first assert statement is green because the string hello world is exactly the same as the string stored in S3. The second assert statement is also a pass because message and S3 are both referencing the same object. And that is the difference between assert equals and assert same. So, what do you need to take away from this discussion? In software engineering, the test-driven development approach, it is sometimes known as test-first development. TDD is primarily a specification technique. It ensures your source code is thoroughly tested at confirmatory level and meets the requirements defined for it. Because every single line of code is tested, you achieve 100% coverage test. Lastly, you end up with much clearer and easy to understand code. And that's it for this presentation. Thank you for watching.